All right. So everything about the clock was created except clicking on the hour hands. So if we look at the hour hands, we do have, I'm sorry, not the hour hands, the hour indicators. For example, this is 2 o'clock. We do have a rotation on the Y. Your clock may have been built differently, but in either case, we went over how there's 360 degrees in a circle and there's 12 hours on a clock face. So you have 30 degrees per hour. So as I move through these hour indicators, you can see that the Y rotation is changing by 30 degrees. And I'm going to use that to understand which hour I'm clicking on. We have a box collider. We have a collider that we can get involved with the physics system based on user input. And we have these layers, which I'll be covering. So layers are super useful to define what you're clicking on. So we're going to be using the physics raycast, but now we have these painted objects that have colliders, and we have these clock parts that have colliders. So we have to distinguish, wait, what are we clicking on? Because sometimes you want to delete the painted objects, and sometimes we want to click on the clock hands to change the time. So we do this with layers. And here's some like default layers that Unity gives us, and these are user defined. So I just went down here and wrote clock face, and I wrote painted object. What really matters is that you look at the numbers here, because these are enumerations. These are strings for you and numbers that we'll use with our code. So when you do write out what parts of the clock or which painted object, you can use your own words there. But I did select clock face or layer 11 for the parts of my clock. And so in the game object here, we have name, tags, and layers. Names we've used before, tags we used to figure out the main camera. If you notice here, main camera, and layers we're using with physics interactions. So if we're dealing with user input, we kind of have to jump over to the click detector in this click position manager script, because this is where we're checking for user input. So there's lots of updates to the script, but I'll be covering them each at a time. So right now I'm going to be looking at this part here. So this is in our update loop, our update event, and it checks once per frame. And here we're checking if there's been a left click. Get mouse button down, only true when there's a click, and 0 for left. And this is true when the user left clicks. And what are we going to do? Well, we're going to take our mouse position. In this case, it's a vector 3, but we're really interested in that X and that Y, left, right, up, and down. Where are they on the screen? And we're going to go find the main camera, and we're going to call screen point to ray, just as we've done before. We're going to create a variable of type ray, a raw object reference, and point to what gets created. And then we're going to create a raycast hit object, our reference, a variable called hit, and we're going to take the two. We're going to take the ray object and the reference to a hit, and we're going to modify it with the out keyword so that it can be written to and we can use it later. An object can be assigned to it. And this returns true. This raycast returns true if wherever the user is clicking, there's some type of object that has a collider underneath it. So in this case, this could be true if it's a part of a clock or if it's part of the painted objects that we paint. So we have to check what did we hit. So whatever we hit, remember we can grab the transform of the object we clicked on, and we can get access to its collider or its transform. And from the transform, we can go up to the game object and then use its layer property. Notice it's an integer. And we check if it's on a certain layer. In this case, we want to go up to the game object, grab its layer property, and see if it's on layer 11. That means it's part of the clock. So if it is 11, that means we are indeed, the user is indeed clicking on one of these hour indicators on the clock. And from there, we can actually make our way up to the root of the clock and get to the clock component. So what this means is when a successful hit happens, we can get the transform of whatever hour indicator was hit. And remember, parenting childs, and parents are referenced through the transforms component. So we'll get the transform on the hour indicator that was clicked. And we want to go up one level. We want to go up to the parent, and that's the clock root. And I know that because I built this game object that has other game objects nested underneath it. So I know how to jump up a level. And I know there will be this clock script object sitting on top here. This one is turned on. So that's where I could say, okay, go up from what we hit, grab its transform, grab its reference to its parent, which is up at the, now we know that we're at the clock root level, and we're going to call get component. And we're going to check and try to get the component at the top there. And I know that there's a clock script there because I did it, so I don't need to do a check. But later on, we'll see how to check if these components are actually, this get component call is actually returning something or not. So then once we have a reference to this clock object or clock component object, we're going to call a public method on it. We're going to call update time. And then we have to pass in some data so that we know what type of hour we're transitioning to. And so whatever we hit, grab its transform. So it's like saying if it was 1, 2, or 3, we're interested in going into the transform and actually going into the rotation. And for my case anyway, getting the Y value here. So that's why it says hit, go get the transform, and then get the local Euler angles. So this is a quick property on accessing the rotation in a simpler way. So if you remember, rotations are handled with classes called quaternions, and it's a complicated math concept. And we can simplify it. So if you want to just read like the X, Y, and Z, so in this case, if we want the rotation as a nice little vector 3 that has 3 components, and we're really interested in the Y component, then we can call this local Euler angles property. And this will give us the rotation and Euler angles, which is a vector 3. But it's also the local version of it. So remember with this idea of global and local. So at this object's level, at this object's transform, we have a very simple rotation. You know, this is the scaling and the positioning and the rotation I had to do to get that nice little 3 o'clock hour indicator. But if you do notice, it is underneath another game object. It does have a parent, which has changes, has updates to its transform as well, so that the clock sits nicely in our UI. But I wish to ignore all this. I don't want to handle that at the same time because that's complicating the math I need to do. So I grab the local Euler as opposed to grabbing the global, which will have also have rotation information at the parent level, any higher level as well. So that's why it's the local Euler angles. And we're passing in just the Y component. So this is like just the property of Y. It's a float. So there's X, Y, Z. It's like shorthand way of like saying just give me the Y. So you can do the same with X, Y, and Z. And actually you can reference them as RGB and A as well for colors. So you have these kind of shorthand rules. Now, so let's go look at what this public, so we're moving from the click position manager object is calling a public method over on the clock component object. So I'm going to jump over there, and here is the public method that it's calling. And so if you remember on the clock, it's going to this object and calling this public method on it. So it's going to receive a float. The clicked arrow rotation. All right, so what's happening here basically is here we know that if we take that and we divide it by the hours, degrees per hour, 30. So for example, if I click on the 3 o'clock marker saying I wish to move to 3 o'clock time-wise, it's at 90 degrees. So 90 divided by 30 is 3. And so on for the rest of the hours. So that's how I can figure out the hour that the user wishes to go to. But it's not as it's not as straightforward as that, because I do have to figure out the percentage of time that I'm keeping. So, for example, we're currently almost at like 120. So we have like the minute hand is over here, but it also starts to rotate the hour. The hour starts moving in between 1 to 2. We have this like fraction of a unit, and I want to keep that. So watch as I go from 120 to 320. Notice that the 3 hand, and I can click on the hours hand here, isn't at exactly 90. You know, we've kept that fraction, that offset. So I do have to kind of go back and be like, okay, I'm going to grab the time continuous variable where I can get access to total hours, so that kind of decimal number of our hours. So in this case, 120 is about 1.3 or 1.4, whatever. It's like a third of the way through the hours. So it's probably like 1.33. So remember, this is a double, and I have to cast it to a float. So I have to get a decimal number of this. Then I also take it and I cast it to an int. So it's like saying 1.33 minus 1. And I just get that 0.33. I just get that fraction of an hour. That's what this is doing. It's like, give me our current fraction of an hour and add it to wherever the user wants to go. So if it's 90, be like, okay, 90 divided by 30 is 3. We want to go to 3 o'clock, and we really want to go 3.33 because we have to keep that 20 minutes. So I stored in this hours.temp. It's a property up top. Our field, it's private. But it's accessible in these methods. And so really what I'm doing here is I'm kind of figuring out, okay, should I be jumping to like 3 a.m. or 3 p.m.? It's like, how do I kind of want to figure out if the user wants to stay in the same lit time area, or do they kind of want to jump ahead like to the other part? So for in the morning, if it's like currently 1 a.m., do we want to move to 3 p.m.? Or if it's 1 p.m., do we want to move to 3 p.m. or 3 a.m.? And the thinking I had here was just, if we're clicking ahead, so currently we're at 3:20, right? I'm going to click there and it's 5:20. I'm thinking if they're moving ahead, they want to move like in the same time bracket. If it's morning, stay in morning. If it's evening, stay in evening. Currently it's evening. But if they click backwards, I was like, oh, maybe they want to jump 12 hours. So as I click backwards, we jumped into AM. Here I'm jumping backwards, we're jumping back into PM. So that's just, you could have different logic. That's just what I wanted to do for my user. But we do some user testing to see if that's what they want or not. But anyway, if we're in the afternoon currently, then I'm going to just add 12 hours to where we're moving our hour hand, because we clicked on 3, which is like 3 a.m., but we were in the afternoon situation, so we just added 12 hours to get to 15. And then I'm just checking, remember hours is like our real time, like since the last time we updated, and this temp variable is just being stored like with the users clicking on, and we're about to like update our real time or hours time with it. And I'm just seeing if I'm in front of or behind. So if I should jump ahead 12 hours or if I should jump behind 12 hours. So that's kind of what this logic here is doing. Should I stay in the current morning or afternoon, or should I jump to the other one? In either case, what we get to is hours gets updated. So hours is what we're using in our update loop to update our hours hand in our day cycle. So that is update time. And that's when I can click here. If we should be jumping, staying within the same kind of time zone, AM or PM, or jumping into PM. And that is now the hour indicators. And so, yes, I'm still painting as I click on them. But that's something that we'll fix later on. But with that, we've completed the building of the clock, the animating the clock. We got the AM, PM, and now we can click on these little hour indicators, which that step involves both the click position manager for user input and calls a public method on the clock script. Great. I think I'm going to stop here.